Okay, here we are. What's going on is we're going to do some more of these labs. We might, toward the end of the stream, do a few review questions, maybe just over network concepts or network implication. Alright, cool. I'm just always worried that the music's too loud. Sometimes I feel like it's in the background, no one can hear it. Cool. We'll, I guess we'll just let it go. Oh, did all those... I'll worry about that later, I suppose. Alright. So, toward the end of the stream, we might do some of these... like the 1 and 2, section 1 and 2, kind of review questions. I don't know. Section 1's kind of a doozy. It takes a lot to review those questions. Also, got rid of my stuff. Let's see here. Let's go here so that way I can check on things. I have scheduled for my test on Thursday, so that's going to be exciting. We'll see how it goes, I suppose. Yeah, it's totally gone. All of my stats and everything from the last one are totally gone. That kind of sucks, but that's okay. It's not that big of a deal. Anyway, my name's ParaDiddlePete. If you don't know already, I do things, tech stuff, networking stuff, play games, just kind of things that kind of interest me at the moment. If you're just now joining the stream, go ahead, like, subscribe, do all of that good stuff. We are going to go ahead and get starting on these labs. Let's do it. Will this read it to me? Because it's still pretty early in the morning, and I would very much like to not have to read as I wake up. That's a negative. That's fine. You are a network technician for a small corporate network. Your manager has decided to switch to a new ISP, Internet Service Provider. The network needs to be moved to the new ISP so that the old one can be canceled. The new ISP is running The new ISP has run a fiber optic line directly to the back of the fiber patch panel in the basement network closet, but the NSA device doesn't have a fiber port, so we're gonna have to put fiber ports. Because the NSA has no fiber ports, you'll need to use a media converter to convert the fiber optic cable to a Ethernet cable. Most media converters use SFP ports, so they can convert multi-form factors. Yes, so they can multiply form factors. The media converter in this lab already has the fiber SFP module installed. Okay, so, okay. Use the following information to make the proper connections. The ISP is connected to ports 23 and 24 of the fiber patch panel. 23 is transfer, 24 is receive. Use the color coding on the red of the fiber optic device cables to identify which is T and which one is R. The white and red is A connector, and that is T, so red is T, and the B is the RX. I feel like it's not necessary to call them connector A and connector B when we like these connectors have three names: red, white, A, and TX. Why can't we just keep them all named? Like, I am cool if we're gonna call it any color coordinate it. That's cool, but like, why is it called connector A and connector B? Like, that's just, I feel like that's dumb. Okay, when connecting the fiber cables, connect the transmit TX port to one of the devices on the receiving TX port on the other device. The fiber cables in this lab have already had their RX and TX connection switched as necessary. You can view the component information in the detailed window of the specifications. In the detailed window. I guess that's this. Okay. In this lab, your task is to move the network to the new ISP. You need to select and install the necessary components from the shelf. Add the required network device to the rack shelf, bottom connection area. Move the Ethernet connection from the wall outlet to the network device. Select the necessary fiber cables to connect the network device to the fiber patch panel. Connect the power adapter to the network device and then plug it into the critical load bank outlet on the UPS using the adapter on the shelf. Use a computer on floor 1 to confirm that the internet is working. So we got a lot of things going on. So first thing we got to do is we need to add the required network device to the rack shelf. And what we got to do is we have to figure out which one's which. Okay, so there's our adapter. Here's our cables. And then here's our converter box. Because the NSA has no fiber ports, you'll need to use a media converter to convert the fiber optic cable to the Ethernet cable. Most media converters use SFP ports, so they can be converted. The network needs to be moved. The new ISP has run a fiber optic line directly to the back of the fiber patch panel. Where's the fiber patch panel? This is it. Okay, it says that it's run to the back of it, but very clearly it is not. Okay, all of those are connected. And then that's connected to the wall. Router Ethernet LAN port WAN. The new ISP is running a fiber optic line directly to the back of the fiber patch panel in the basement network closet, but the NSA device doesn't have a fiber port. NSA device. What is an what? Hold on. The term NSA device refers to well, hey, you know what? Let's have this. No, dang it. Two key areas in NSA certified encryption device. I feel like that's not right. What does it do? What does the NSA do? The national security... No, that's not what I want. A file detected storage device that makes data continuously available for employees to collaborate effectively. Okay, so the NSA device doesn't have fiber. You'll need to use a media converter to convert the fiber optic cable to an Ethernet cable. Most media converters already know this. Use the following. So what is this? Okay, this is the router. This is a switch. This is another router. So okay, so because one router's bad, one router's good. I'm assuming that this is the wrong router. Well, let's just start unplugging things, I guess. Add the required network device to the rack shelf. Okay. What? Okay. Okay, we don't need you. You go away. So we need to connect the fiber. What does it say about port 8? Said something about port 8. I thought, no, port 23 and 24. Why do I need to know port 3 and 24? Okay, if this is connected to this. Where are these connected to? Port 3, server rack U1 motherboard socket. Where? Oh crap! What are you? Oh, come on. What are you connected to? I think you're connected to the wall. Yeah, you're connected to the wall. It said that it had a fiber line that was coming into the back of the fiber patch panel. I always thought that this was the front, but I guess that's the back. Okay, cool. So the ISP is connected to ports 23 and 24. But it's not. Am I supposed to connect it? Yes, use the following information to make the proper connections. Okay, so A needs to go into 23. And then B needs to go into 24. I don't know why that makes sense. Yeah, because I don't know what I'm doing. There's no way that's what it is. I feel like this is really dumb. What? Okay, whatever. And then somehow it magically has internet? This doesn't make any sense to me. Score the lab. What'd I do wrong? I made a 40. So add the media converter to the basement workspace. Well, I did add the media. I did do that. Oh, I didn't power it on. Move the Ethernet cable from the wall outlet to the media converter Ethernet port. I thought I did that as well. Plug in the media converter. Yeah, I did not do that. Let's try it again. There's no way it does. There's no way plugging in one cable into a wall is going to give the entire building internet. Like, am I crazy? Is that how that actually works? I feel like that's not right. Okay, that goes into there. Okay, so we don't need this because this is the old one. Okay. So basically we're replacing this with the media converter, I think. Because the wall was going into this. So the wall, where's the media converter? I was supposed to also plug it into the UDP. Yeah, see, I added it. Hey, look, added. So I don't think. See, I don't know why that's plugged in. I don't know what that's doing. But we're going to plug that in. And then we're going to plug it in over here. And then... Huh. So that's considered the back then, huh? Interesting. I would have not have thought that was considered the back. I would have thought that was considered the front. Or sorry, I would not have imagined that that was considered the front. I would have thought that was considered the back. Okay, where are these plugs going? Which one's the monitor? Neither of them are the monitor. So what are these plugs going to? Okay, that's fine. So that's where our adapter comes in, right? Yes. Okay, so now we got power. Now we just need to connect the fiber. It's going to be connected to this. And then A is going to go into port 23. Port 23, and then we have port 24. Okay, that makes sense. So now we have... I guess this port is giving internet. I suppose. That's wild to me that... I mean, I guess that makes sense. I don't know why that's so wild to me. Okay. But this, I don't know what this wire is. Like, what's this wire doing? Use the color coordinating. Okay, did that. Add the required network device rack to the shelf. We did that. Move the Ethernet connection from the wall outlet to the network device. Okay. Okay, we don't need this. God dang it. Okay. Oh, this needs to be turned off and unplugged. Turn off. Move. 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 Okay. So now we have... This is plugged into this, but... But now... Okay. Wait, am I done? I guess let's find out. Let's go to the floor 1. Hey, what's up, Oaks? Fiber's kicking my ass. No internet connection. No internet access. Okay, well that tells me that. So let's go back to the basement. Let's go back here. Let's think about it. It's all about where information's coming, where information's going. I don't know what this wire's doing. Like, what's the point of that? Select the necessary fiber cable and connect it to the network device to the fiber patch panel. Connect the power adapter device, then plug it into the critical load bank. I did that. And the UPS using the adapter on the shelf. I did that. Use a computer. Okay, so my problem is somewhere in the connectivity. Is this supposed to go in here? I guess what I'm having a hard time understanding is that the beginning of the scenario says that the new ISP is running fiber optic line directly to the back of the patch panel. Where is that line coming from? Like, I don't see a line that's running directly to the back of the patch panel, unless that's like, if it's running fiber directly to it, shouldn't there be a mount somewhere that has a fiber line coming in from outside? Okay, I just moved that wire. Let's check and see if that's better. I have internet access now. Okay, I think I did it right, but what I don't understand is some of the wording and some of the placement of stuff. So like, what's going on with these channels? Why are they plugged into here? What's going on with channel 23 and 24? Why did I have to convert that to make it go into the router? I don't necessarily understand. Like, I did it correctly. I just don't necessarily understand why I did. Okay, WAN. So that's the WAN. So maybe I just don't. Maybe they just didn't show me where. Because that's 1, 2, 3, 4. If I look at the back of it. My thing is, I don't know where the internet's coming from. But I guess I don't need to know that part. Let's see if I get it right. 40%. Add the media converter to the basement workplace. I did add the media converter. Is there a certain place I'm supposed to put it? Plug in the media converter. I did plug in the media converter. Connect AC to DC power adapter to the C12 power adapter. Add the... Okay. Let's read when it says... You gonna do it? Probably not. It doesn't like this program. Okay. Add the media converter to the rack. Where can I add the... I tried. It told me no. It told me no. It went... It went no. Undershelf expand network device. Drag the media converter to the bottom shelf of the rack workspace. Well, how was I supposed to know that it needed to go to the bottom shelf? Convert the convert the CS to the LC. cable to the media converter above the rack. Select back to switch to the back view of the rack. Drag the Ethernet cable from the left wall outlet to the Ethernet port on the media converter. Under shelf, expand cables. Select cable fiber. Move the Ethernet cable from the wall outlet. Okay. Drag the fiber cable A to 23, B to 24. I did that. Okay, let's try it again. So, apparently... Man, I'm about to go grab myself an apple. I've been doing nothing but eating candy for the last, like, 2 days. Okay, so... This network device is supposed to go... That's stupid. Oh my god. Okay. So that's there. No, you give me the wire. I want the wire. Okay, we don't need that anymore. No, what? I can pick up the what? How is that realistic? Since when can you just go to a wall outlet and be like, "Hey, man, I don't like you right there. We're gonna pick you up and we're gonna move you over here." Okay, turn it off. Unplug. And then we'll unplug again. Okay, we're also going to move this over here. Take this, we'll move this over here. Take the adapter. We need it to be there. Cables. Let's plug in. That's... I'm not believing that this, like, that doesn't make any sense. Like, why does this have to be this way? Why does this have to be the back and the part with the power have to be the front? That literally makes no sense when the rest of the rack is the complete opposite way. Like, why, and why do I have to put it like that? Why can't I just turn it around? That's really dumb. Because now all I see is the power. And all the other connections are there. That's real. That's like mega dumb. Like, am I stupid here? Wi-Fi power outlet. Like, this is so small, it makes no sense that it's shaped this way. It should be, like, I should be able to just flip it. Like, am I crazy? Okay. Because now, I gotta go to the back to select this wire, to go to the front, to connect it here. Okay. So then, is that correct? Let's find out. I have internet access. So I guess I did it correctly. I got a lot of questions. Question 1. Why does the orientation of this box matter so much? I get it that it needs to be in the rack. Okay, cool, whatever. But like, why is it this way? Why can't I flip it around so that way it matches the direction of the imports on all of the other crap? Especially with what I need to plug in is right there. But then again, I guess that means that the wire would go in the back and then wrap around, or it would just be hanging. Or why does it have to be at the bottom? Why can't I just put it at the top? I have questions. Okay. Other thing is, I guess this port is doing something. I just don't know. Let's see here. Tell me that I didn't make a 100. Move the Ethernet cable from the wall outlet to the media converter Ethernet port. I did that. Okay. Connect the LS to the LC fiber cable to the media converter. Above the rack, select black to switch. Oh, select back, not black. Select back to switch to the back view of the rack. Drag the Ethernet cable from the left wall outlet. That's exactly what I did. Port to the media converter. Okay, I did that. Under shelf expand cables. Select cable fiber LC to LT cable. From the selected component panel, drag the connector fiber duplex LC male connector to the media converter. Connect the LC to our SC to LC cables to the patch panel above the rack. Select front of the switch in the front of the rack. Above, select component pane. Okay. I don't understand. I did this. Move the Ethernet cable from the wall outlet to the media converter. Let's ugh, come on. Load. Takes forever for it to load. Let's see what I did wrong. Let's see if someone else on YouTube did it.
Hello, Turkey. Select the necessary work at your own pace, and see the slots that we have. Okay, so let's see the ports available. So this is the ports for the fiber optic cable. We're going to unplug this. Plug this. Plug this into this port here. And this fiber optic cable. This is port 23. This TS24 is RX. So
Okay, that's exactly what I did.
plug this into this port here. And let's go to the front.
A goes to 23.
Into this port.
B goes to 24.
Into this port.
Okay, cool. Got it. We're good. Yeah, because we went to the priority. Okay, I did all this. So show me my mistake. I want to know what my mistake is. Wait, hold on. The scenario said that you needed to remove the old one. That's even here. Add the required device network. Sorry. Add the required network device to the rack's shelf. Oh, this is the rack shelf. No, that's the shelf. This is the shelf. So you don't have to remove this? No. Okay, you are a network technician for a small corporate network. Your manager has decided to switch to a new ISP. The network needs to be moved to the new ISP so the old one can be canceled. The new ISP is running a fiber optic line directly to the back of the fiber patch panel in the basement and closet, but the NSA device doesn't have a fiber port. Because the NSA has no fiber ports, you need to use the media converter to convert the fiber optic cable to the Ethernet cable. Most media converters use SFP ports so they can convert multiple form factors. The media converter in this lab already has this. Okay, following the information, use the color coordinating. So, bottom connection area. So it's calling this the rack shelf, and this is just the shelf. So am I just an idiot? That's probably the case, I suppose. Oh. Yeah, that's what I thought. Okay. Okay, so that's there. Cables. God. We might switch, that way I'm on my bigger monitor. Go to the back. We have this. This is going in here. So then how did I do it so that way I still had internet connectivity? Huh? Okay, that's connected. That's connected. And let's go back to the back. Adapter here. And front, back, connect. Oh, because what I did is I bypassed this router. And I went directly to this router. So I guess you can do that. Okay, I just did everything that guy did. Well, spank my ass and call me Shirley. Interesting. Okay, let's keep going. Let's try another one. Install a switch to the rack. I need to not overthink these things.
You are a network technician for a small corporate network. Your manager has asked you to install a new switch in the networking closet. Once installed, connect additional devices using Cat6A cables to test connectivity. Use the following information to install the switch and connect devices. Add the new network switch near the top of the rack, under the existing router. Provide power to the switch by connecting it to a critical load bank outlet on one of the rack UPSs.
Okay.
Use the AC power cable with C14 end. Use Cat6A cables to make the following connections. Port 5 on the switch to Itadmin, port 5 on the patch panel. Port 8 on the switch to lobby, port 8 on the patch panel. Port 24 on the switch to the LAN 1 port on the router. Port 21. On the switch to the left network port on Corp server, select each server to view the name in the selected component area. Port 5 on the switch to Itadmin, port 5
Okay, and then we need a ping. Okay. You are a network technician for a small corporation. Your manager has asked you to install a new switch in the network closet. Once installed, connect additional devices using Cat6A cables. Use the following information to install. So we need to add a new network switch near the top of the rack. Added. Okay. Provide power to the switch by connecting it to the critical load bank outlet on one of the UPS. Use the AC power cable. Okay. That's not right. There we go. And then I think switches just automatically come on. Yeah, they're just automatically on. Okay. Use Cat 6A cables to make the following connections. Port 5 on the switch to port 5 on the patch panel. So 1, 2, 3, 4, 5 to port 5. Whatever. Port 8, 6, 7, 8 to port 8, which is the lobby. Port 24, 22, 23, 24 down here to the LAN 1 port on the router. Man, my knowledge of this stuff is still like very like elementary, because like I don't understand why there's 4 LAN ports. Like what is that part of like the like it's clustering it together? Like what's the point of having 3 LAN ports? What does that do? I'm sure that it'll explain it to me eventually, but I'm curious. Okay, and then we have port 21 on the switch to the left of the network port on. Okay. So port 21. Yeah, okay. On the switch to the left network port on the server. Where does it go? This goes here. And like, do these, because it specifically said to the left, does it matter? Like, does it absolutely matter which one's which? Select each server to view the name and the selected component area. Ping the corp server IP address from the lobby. We're going to ping 192.168.0.10. Okay, that should be it. We should be done. 100. Man, some of these are really easy. It's only when it deals with fiber that I double guess myself. And I'm like, I don't know. I can't wait till we get to like network addressing and then like routing and advanced switches. Like some of this stuff is going to be like crazy cool. In this lab, your task is to create a new user account with the following settings. Username, IT switch admin, password, admin only, 1844 with a money sign in between. User level, read, write, manage access, 15. Edit the default account as followed. Cisco, read only, save the changes. Okay, so we need to secure it. Access the switch manager console through Chrome. Okay, let's try it. We're starting to get into like harder things. More than just plugging in wires. When I became a band director, I'd be like teaching the kids, and I'd be clicking my sticks together. I was like, bro, I got a music degree, so that way I can click sticks together. Maybe something's wrong. And now I'm like, Man, I'm trying to get these certifications, and I'm trying to do more than just plug in wires. Okay, you are an IT security administrator for a small corporate network. You need to secure access to your switch, which is still converted to the default settings. That's not good. We don't want that. Okay, access the switch manager console through Chrome. Okay, let's go to Chrome. And then let's go to 192.168.0.2. Look at that. Okay. The username is IT switch admin. Password is going to be admin only 1844. Wait. I skipped a step. Cisco. Whoa, what? No, go away. Okay, so we want to change device password, but we want to do more than that. Create a new user account with the following. Wait, so was I not supposed to log in like this? There it is. Okay. IT switch admin. Password is admin money sign only 1844. Admin only 1844. Wow, it's saying that my password is weak. I also typed it in wrong. ADMIN money sign only 1844. And then just to be safe, AMIN money sign only. There we go. Still weak. Got it. The password and confirm password fields must be identical. Okay, I guess I misspelled something. ADMIN money sign only 1844. Let's try this one. ADMIN money sign only now let's try it. Success. Password needs to be CL Okay. Save the changes to the switch startup. Save the changes to the switch's startup configuration file. Okay, I think that's it. Copy / saved, done. Wow, so you don't have to like go into the command prompts like how I did with my CCNA and it's like and like do it all through there. Like you have this web browser that can just manage it through this really awesome like interface. So then why did I learn all of those commands? I think I'm done. Yep. Sweet. Okay. In this lab, you are practicing entering in commands to navigate through the command modes. Okay. It's been a while since I've done this.
Select the SFO router and press enter in the terminal window. The initial command prompt is the user exec mode, where basic commands and troubleshooting can be performed. Type to see a list of commands available in this mode. Each mode will have a different list as more access is granted. If the output from a command exceeds the screen, you will see more at the bottom. Try using the enter or spacebar keys to navigate the output. Answer question 1. To create a shortcut, you need to find characters that uniquely identify a command. For example, type S to see commands that start with the letter S. Notice that SHIST would uniquely identify the show command. Type SHH, and you can see that show history can be replaced with SHI or SHHist. Type SHH and answer question 2.
Yeah, that's why you put like IP config instead of IP configuration. Okay. Alright, I'm gonna turn the air down. It's cold. Whoa, that's dope. That's way better than the packet tracers. Like, Jesus. Okay. In this lab, you will practice entering in commands, navigating through the command modes, and the Cisco iOS. Finding entering commands. Commands can be and usually are abbreviated to save time typing them into the command line. Select the SFO router and press enter. Okay, we're there. The initial command prompt is to get into exec mode where the basic commands and troubleshooting can be confirmed. So, but I need to be in privileged exec mode. No, I gotta go to exec mode first. Where basic commands type. See, I need to be in privilege exec mode. Man, I do not remember how to do this. See the list of commands available in the in this mode. Each mode will have a different list as more access is granted. If the output from the command exceeds the screen, you can see hit enter or spacebar to see more. Answer question 1. Okay, how far does pressing the enter key advance you? Oh crap, I don't know. Just one line. Using the results of the shv command, what is the smallest abbreviation for the command version? Okay, create a shortcut. You'll need to find characters that uniquely identify a command. For example, type S to see commands that start with the letter S. Notice that SH would uniquely identify the show command. Type SHH and see, and you can see that it shows history. And you can repeat that SHI or SH hist. Type SHV and answer question 2. SHVE. Enable. I want to privilege. So that is what it is. What happens to the command prompt after entering CompTIA? Let's find out. I've never abbreviated it like that. Navigate. Navigating router modes. Access the advanced commands and configure modes. Enter EN or enable. Wow, I've never put it EN. I didn't know you could abbreviate it that much. This will change the privilege exec mode. Answer question 3. I already did that. Okay. The exit. To exit this mode and return to exec mode, just type enter disable and enter and notice the change in the command prompt. Re-enter exec mode mode by entering EN. I always put config term. I never put config T. I didn't know you could. To change it to global config mode. In this mode, you can alter router settings and access individual components. Answer question 4. What happens to the command after prompting FAO/1? That should, yeah, fast Ethernet. Yeah, so now I'm in config. Now I'm configuring the interface of Fast Ethernet 1. Oh, whoops. Okay, so it literally was just kind of showing you stuff. That was good. That was good. I haven't like legitimately done a packet tracer or any type of Cisco stuff in like over a year. So that was a good little refresher. Ooh. Hey, what's up, man? How's life? How's it going? Okay, as a network administrator, you have decided to implement port aggregation and combine multiple ports on your switch to increase throughput and provide redundancy with automatic failover and failback. In this lab, your task is to log into Cisco Switch Console from the Google Chrome. It's already up. Create a new link aggregation group named Windows Server. Enable the link aggregation. Okay, let's go ahead and let's do it. Cisco password. That's real. What? There we go. I was about to make a joke about how, like, that's not really secure, but then again, I wasn't able to get in, so yeah. All right, let's get back to it. Create a new link aggregation. New link. Can I? No. Dang it. Where would that be? It was out here and I just didn't see it. Does anybody see where it says new link aggregation? I feel like I'm looking for strawberries in the refrigerator. So okay, I guess we'll go through all these. And control. Oh, is it an access control? No. Check smart port. Smart port settings. Nope. And port management. Well, let's check it out. Link aggregation. There we go. Yeah. For the win. Create new link aggregation. LGA1. Oh, no. That's not what I want. This is it. Create a new link aggregation. Group LG1 name. Windows Server. But how do I name it? Thought maybe it would prompt me to name it. Oh, there it is. I just didn't see the prompt. It was all white. That's why dark mode's better. Windows Server. Okay, close. I did that. Configure LG to use address VLAN mode. I don't know how to do that. Configure LG1 to access VLAN mode. Default VLAN ID. VLAN settings. Ah, interface. Is that what I want? No, yes. No, we want to configure the entire lag 1 to access VLAN mode. So maybe it's back in join lag 1 to VLAN 13. It's got to be in VLANs. Maybe it's back over here. Maybe I just missed it. No. No, that's all done. I don't think enabling that's going to do anything. So I do try to stream a little often. I've been picking it up a whole lot more the last few weeks. I'm actually a school teacher, so I don't stream. It's very soon. I'm not going to be able to stream in the mornings because I'll be teaching. But in the evenings, I'm going to hope to try to be doing more of this stuff. I'm trying to de-Wi-Fi my house and like trying to control my data a little bit better. So I'm in the process of building my own server and doing things. So the best thing, I'm a teacher. So the best thing I thought about doing, I was like, well, why don't I just get, I could watch endless amount of YouTube videos and fumble through it, or I could just get certified in the stuff and have a gentle understanding, and then I would at least have enough knowledge to ask questions. You know what I'm saying? I hate when I want to do something and I don't even know enough in order to ask a question like that. That drives me insane. Like right now, like I don't understand what it means to configure LGA to use access to VLAN mode. Like I don't even know enough to like how do I give it access? Like what do I click? You know what I'm saying? So that's what I do. I also play a little bit of video games and stuff. I used to play a lot of video games and things. I still do, but I don't make as much content with that anymore. It just got I don't know. It's not that it's bad or anything. It's just life kind of got in the way. You know what I mean? Are you a network? Are you a technician? Okay, we are.
Hello, techies. We are producers to configure lag 1 to VLAN.
doesn't even know. See, this is what I thought. I thought I needed to select them. Oh my god, it was a drop down screen. Ugh. Oh, there it is. System engineering. Wow, that's pretty cool. So what kind of things do you do like on the daily? What's a normal daily task that you would have to do? Okay, join lag to VLAN 13. Nice back end stuff. See, this is what I thought. Why is he zooming in on it? Now I'm unemployed. I just resigned due to night shift. Oh man. So so you resigned because they put you on the night shift, or you resigned to the night shift? See, I need to know this stuff better so that way I can, like, he's fumbling in the dark like I am, but he knows more, so he's able to what? Oh, they put you on the night shift. So since they put you on the night shift, you were like, "Nah, dog, I'm out." And you walked in there. You walked straight to your boss. You walked straight to your boss. You had a stack of papers, and you were like, "Look, I'm gone." And then you walked out the door. This guy's struggling trying to find it too. They put you on the night shift on purpose to try to push you out. Okay, that was it. What do you do? Where do you go? Dang it, I missed it again. I was itching my eye and I missed it again. Wait, so your work is only the night shift? No, my work is like that only. So, like, your job is just always the night shift, and then you were like, oh, I got put on the night shift, so I'm gone. You know, there's a guy that I used to work with. He was a coach, and I don't understand why football needs so many coaches, but he was one of the coaches on the football team, and whatever position he was doing, they were doing really, really bad, and they brought him in to talk to him, and they were basically just kind of like berating him the whole time, and this is rumor, you know, I wasn't there, this is just the rumor I heard, that he was sitting there, and they were like, well, we got to figure out what we're going to do, what can we do, and he like sits there, and he's like, well, let me tell you, I think I have a solution that's going to help and benefit all parties in the room. And they're like, really? What is it? He goes, I quit. And he just gets up and he walks out of the room like a boss. Okay, what are you clicking? VLAN membership? Go. Okay, we're going to go here. Join VLANs. And we want to join VLAN 13. Okay, that makes sense. VLAN membership. We gotta. Okay. Verify the status of the new thing. So we're going to apply. Success. How are we going to verify this? Are we going to ping it? Yeah, and that dude, they didn't let him out of his contract, obviously. And, whoa. And anyway, they took him out of the classroom and they made him a credit recovery teacher. And since he'd been a teacher for like 10 years or 15 years and he was a coach, what happens is that you get 5 sick days from your district and you get 5 sick days from the state. And the way it works in Texas is that the days that you get from your school stay with your school. The days that you get from the state can travel with you. So he had like, I don't know, like 30, 40 days saved up. That fool only came to work on, I think, Wednesdays and Fridays for the rest of the school year or something like that. He was a man after my own heart. Like, it was so funny. Okay, I wanted to make sure. Okay, I think that this is correct. Lag manage. Yeah. How are we gonna verify? Okay, so we need to go to lag management and verify that the link is up. That makes sense. The link is up. So let's answer the questions. Is the current link state of lag 1 up? Yes. What are the active members of lag 1? These. Score lab. Dang, create a new I thought I did that. Show details. Oh, I didn't enable that. Actually, I legitimately went in and disabled that. What is the LACP? What is that? LACP. Good old Gemini. I actually don't like Gemini very much, but it's good for little one-off questions like this, and I know that it's not going to save them. Link aggregation. That's a hard word to say. Link aggregation control protocol defined by the IEEE 802.1ax standard. Bro, like, technology's magic. Like, I'm just like, that's it. Like you watch video, or you watch like movies in anime where like they're saying these incantations and they're basically like speaking in tongues. Like let's be real here. Like how does this work? Well, the IEEE 802.1AX standard, formerly known as the 8002.3AD. Like that's a spell. Like in simpler terms, oh, here we go. We want simpler terms. Read it to me, Jessica. Read it to me, Jessica.
In simpler terms, imagine you have two switches connected by several Ethernet cables. Instead of treating each cable as a separate connection, LACP allows the switches to act as if they are connected by a single, high-capacity cable that combines the bandwidth of all the individual links.
Okay. We're going to do this again just because I'm not familiar with this interface. And I'm sure that the interface is always going to be different depending on whatever, but like I just want to get familiarized with it. It's kind of like once you learn Photoshop, like you can use anything. Once you use Microsoft Word, you can kind of use any Word document. Like there's only so many that you know, they're all kind of the same. Cisco. Oh, hold on. Someone's calling me. ACU. Ooh. That was my bank. I paid off my car. And they're like, oh, we can't help but notice that you are no longer indebted to us. Is there anything we can do to entice you to make you become indebted to us again? No, there is not. Thank you. Go away. Okay, VLAN management. Okay, edit. It wasn't in here. Where was it? Oh, it was in membership. It was in membership. Oh, let me turn down the jams a little bit. Lag. Join VLANs. You go back over here. You go over here. Apply. Okay. And then link aggregation, membership, link status is up. And that should be a 100. What? I did that. I'm sorry. I didn't mean to scream. I just get passionate. Oh, I forgot to give it its name. Maybe I forgot to hit save. We'll do it one more time. I was also on the phone while I did it too. I was distracted. You know, those jams are good, but I want to hear these jams instead. Is it gonna go? Oh. There we go. I'm thinking about starting another channel where I just post like some music. I don't know. I feel like it'd be easy views, and then I would never get copyright right claimed again. You know what I mean? So we need to go to Smart Port, was it? No, it's port management. Yes, port management, link aggregation, and we want to go to crap. No, this is right. Whoa, 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 whoa. Here, here, enable, and then Windows Server. Okay, apply. So that should be it. Okay, the link is down at the moment, but that's okay. We're going to fix that. Now we need to go to... So we just did this. We named it that. We added those two GE1, GE2 as lag members. Now we need to configure lag1 to the access to be able to access VLAN mode. So VLAN membership, lag, go here, join VLANs. I don't know. I don't think we need this one. We're gonna go here. We just want it on 13. Verify that the status of the new lag1 group. You know what? Go ahead. Why not? Verify the status of lag1. I think this is correct. So then apply and then exit. I feel like I did all this. Let's just make sure. Whoops, that is not what I wanted. Okay, that's what he did. Mm-hmm. Ah, what is this? What did he do? Oh, he didn't. Oh my God. So now it's saved. That makes total sense. I should have saved it. Whoops. All right. Mama didn't raise no scrubs, you know what I'm saying? Enable jumbo frames. All right. Let's do it. We might take a break from some labs and do some test questions here in a second. My exam is on Thursday after all. Hate when I get whiskers. Ooh, I need to schedule my hair appointment. I need a beard trim. Look a little scruffy. Okay, Google Chrome access, switch console as follows. Site is this, username is Cisco, password is Cisco, and log in. So then we need to enable jumbo frames. I feel okay. Let's think about this before I break down and use YouTube. Where would jumbo frames be? I feel like that would be in port management. Gosh, dude, I can feel it. Jumbo frames. Ah, yes, okay. Enable jumbo frames. Save the configuration changes made to the switch. No way it was this easy. Reboot the Cisco switch. Okay. How can I reboot it from here? Nope. Okay. So rebooting the switch has to be something that's in here. Initial setup, create VLAN device, configuration, change appliances. Maybe that'd be in administration. System settings. No, this is the account. Reboot. Immediately. And then we need to log into Cisco and check the status for any errors. Shouldn't be any errors. How do we check it for errors? Log into the Cisco switch and check statistics for any errors. Here. I'm assuming that means that there's no errors. How many combined undersized packets, oversized packets, fragments, and jabbers in collisions are there? 0. True or false? Now that jumbo frames are enabled, was I supposed to check this out beforehand? No. Are enabled. Network devices should also be configured to use jumbo frames and have frame size larger than 15 bits. True. That we need to increase the MTU, the maximum transfer unit, I think is what it is. All right. Okay, some of these are really easy, and I feel good about them. Some of these I struggle profusely, and I have a really hard time. Maybe we'll finish this chapter out, and then we'll do some test questions. And then I'll go eat lunch, and then I'm going to come back around 4. All right. Here we go. Cisco, what are we doing? You have purchased a new power over Ethernet security camera and have plugged it into port 23 on the Cisco switch. You need to make sure that the security camera has power and critical priority on the switch. Okay. In the lab, your task is to complete the following. Okay, we're already there. Set the power over Ethernet, PoE, switch properties to class limit. Answer the questions. So PoE, where would PoE be in? Okay, it would be under port management, okay? So we're gonna go here, and we need to make sure that properties to class limit. Now, hold on. What does that mean? PoE port limit versus class limit. Ooh. I hate when my fat fingers hit things. What is class limit versus port limit? That's what it is, right? Yeah, port limit versus class limit. What is that?
Class limit versus port limit. In power over Ethernet co-enabled switches, you'll encounter 2 ways to manage power allocation. Class limit, sometimes called auto mode, and port limit, sometimes called static mode. 1. Class limit auto mode. This mode allocates power to a port based on the detected code class of the connected device. Code classes categorize devices based on their power requirements, ranging from low power. Devices like work phones, class 0 to 3, and high power devices like hand-tilt zoom PTZ's cameras, or laptops class 4-8. When a device connects, it announces its class to the switch, and the switch allocates the corresponding power level. For instance, a switch configured for class limit might allocate up to 15.4 WPO for a class 0-3 device, or up to 30 WPO plus for a class 4 device. 2. Port limit static mode. This mode lets you explicitly set a maximum power wattage that a particular port can provide, regardless of the connected device's PO class. If a connected device's class requires more power than the configured port limit, the switch may not provide power to that port count. The actual power consumed by the device is what's factored into the switch's overall power level, not the configured maximum, notes the router switch blog. However, if the device attempts to draw more power than the set limit, the port might be shut down, says Cisco Systems. Key differences and implications. Flexibility. Class limit offers more flexibility as it automatically adjusts power based on device needs. Port limit provides granular control over individual ports, but requires manual configuration of power budget management, while class limit uses the device's advertised class for allocation. Port limit tracks the actual consumed power once the configured limit. This difference can impact how you manage the switch's overall power budget. Legacy devices. Some older devices might not accurately report their PoE class. In such scenarios, using port limit with a manually set maximum could be necessary to ensure proper power delivery or to protect the device from damage. According to Pearl's Stock advanced features, some switches, especially modern ones, comply with PoE plus 802.3 AT or PoE plus 802.3 AT. Might ignore the device's class and port limit mode,
Huh.
allowing you to define a higher maximum wattage.
Okay, so basically what it is the limit of how much energy goes, it's either it's going to auto detect, or I can statically put it. So what this is wanting us to do is so let's see here. Class is auto and port is static. It wants us to change it to class so that way it's auto. Okay. Configure the PoE port. Okay, answer the question. How many watts of power is the security camera currently using? Power trap threshold. 180? What? Normal power, consumed power. How many watts of power is the security camera currently using? I think 10. How many watts of power is available on the switch for additional PoE? 170. I don't know if I answered this correctly. I don't know if it's 180. Huh. Okay. We need to configure PoE priority for port GE23 to critical. So where is... There it is. So we need to go to GE23 and we need to make it a priority. So it's critical. Power level, priority level is critical. Save the changes. Done. Save the changes to the switch. Startup configuration file. Oh, I did that. Okay, let's see if that 10 watt is correct. I feel like... I'm not sure. No, it was. It was. Okay, cool. Cool. All right, 2 more and then we're going to do some practice questions. Oh, feels good. It's a good morning. Although it's almost afternoon. All right. I feel like this one might be a little bit of a doozy. Let's see what's going on here. A computer, so we're troubleshooting disabled ports. Okay, a computer in one of the offices in your building is no longer connected to the network. Some maintenance was performed in the network closet over the weekend, so you suspect that one of the changes has caused the issue. I feel like that's just a little loud. We're going to turn it down just a little bit. I also feel like that's kind of annoying too. Yeah, it's fine. In this lab, your task is to determine the cause of the issue by focusing your troubleshooting to the Office 1 computer and the path of the network closet, including the following troubleshooting steps. Replace the Cat6A cable connected to Office 1 computer to rule out a bad network cable. Connect the configuration of the switch for errors that might cause the problem. Okay, you'll need to access the switch where Most of the maintenance was done over the weekend. Access the switch management console from the admin computer using the credentials. All right, so first things first. Says we have an IP address. Says we have internet access, but I'm an admin. So let's go to Office 1. And let's replace this cable first to see if it's broken. Oh, crap. Okay. There we go. And let's see. Still no internet, so it's not a bad cable. Okay. Connect to roll out a bad network cable. Check the configuration of the switch for errors that might cause the problem. Okay, let's go to the switch. Okay, port 3 is down. Port 3 is going to Office 1. Okay. Let's make sure that it's not this cable. Nope, so it's not that. This port is also down. I don't know what's going on with that. So, what we need to do now is we need to figure out why this port is down. So, let's go back to the... Oh, no, it wants me to use the admin. Okay, so we're going to go to 192.168.0.2. We're going to use IT switch admin. Then we're going to use admin only. Let's do it. Okay. So I first want to go, I'm assuming I want to go to port management. Let's go to smart port. Okay, let's go back to the closet just to make sure. This is port 3. So we have port 3 on patch panel RJ24. It's going to port 3 on the switch Ethernet 28 RJ port to SPF. Okay. Access the switch management console from the IT admin computer using the following credentials. And then I guess check the configuration of the switch for errors. So is the error this? Why do I have cameras? Okay, whatever. It's got to be in the interface. Where was it? Oh, there it is. It says down. Oh, was I clicking 8 earlier? Edit. Is it really this simple? I'm always shocked with how simple the answers always are. Very rarely is it complex. Save. So now we're up. So we go back to Office 1. We have internet access. That was the problem, right? If we go here, port 3 has it. Okay. I'm always shocked with like how like sometimes it's literally just a button. Like, wow. Okay, let's see what's going on. You manage several network devices in a network closet, specifically a single router and 3 switches. The router is connected to the internet and a single switch. Each switch is has network ports that must be enabled to allow computers to communicate with each other and the network. The switches have redundant connections to have redundant. The switches have redundant connections to each other, uplink ports. They need to be enabled properly to avoid creating switch looping. Okay. In this lab, your task is to complete the following: enable all of the necessary ports on each networking device that will allow the computers and the devices to communicate. So we need to enable all the necessary ports. Make sure you don't create a switch looping. Make sure that any ports that could create a switching loop are disabled. To enable or disable a port, select the port and enable port will show an active light. Select exhibit. Okay. Oh, okay, so it's that simple. I don't feel like it's that simple in real life, but that's okay. Okay, so hold on. Can I not click on these wires? Like, how do I know where this wire goes? Okay, I know what switch looping is, where it gets stuck in this loop, but tell you the truth, I don't necessarily know what it looks like. And I can only see the front. I have nothing in my shelf. So this is connected to this. This is connected to this. This is connected to this. So that's our circle. Switch here is connected to this switch. This switch connected to this switch. That switch is connected to here. How do I know if I created a... Like, what happens if I put it all on? Absolutely nothing. I don't know... Okay, am I missing something? To enable or disable, just select the port. Oh, okay. Well, that's super helpful. Okay, so port 1 is connected to a computer. Port 3 is connected to a computer. Port 5 is connected to a computer. 23 is connected to the router LAN. Uplink port left, connect switch 3. Okay, so these 3 are connected to computers. Doesn't tell me what computers they're connected to, though. Okay, I feel like all of these need to be on because they're all connected to a computer. It just doesn't say what computer. Uplink port left. Switch 3 up port link left. Okay, let's think about this. So top switch is connected to switch 3 and switch 2. And then switch 2 is connected to switch 3 and switch 1. Switch 3 is connected to switch 2 and switch 1. Switch 1 is connected to switch 2 and switch 3. Okay, I think the only way I'm going to know this is to get it wrong. And for it to tell me. Enable all the ports on the devices. What? I missed a port? Oh, I forgot to turn that one on. Enable the link between 2 of the 3 switches to prevent switch looping. So does that mean in order to prevent switch looping, like I literally just decide which ones I turn on and which one I turn off? Like there's no method to the madness. There's no like, well, it's better to have the connection between 1 and 3 off. To complete the lab, do the following. Enable all the ports on each device. Select the internet and LAN port on the router to enable ports. Repeat step 1 for all ports. Switch 1, 2, and 3. Prevent a switch looping. Select disable at least one of the redundant connections. So it literally is that simple. Why do I always think that this is way more difficult than I think? Because, like, okay, all these need to be on because they're all going to computers. We know that because of this. Okay? This is the internet. This is the LAN. That needs to be on. So we're going to do switch 1 to switch 3 and switch 3 to switch 2. And then that should stop. That should stop it, right? It's literally that simple to stop switch looping. Here, this entire time, I always thought it was like this, like, what is going on? What are we listening to? Interesting. This whole time I thought it was like this big deal. Like, I mean, it is a big deal, but it's not at the same time. Okay, we're going to take a break on that stuff, and we're going to look at some test questions here. Give me 1 second. I'm going to log back in. All right. So what I got wrong on this one was that there is nothing that you're supposed to do. And what I got wrong on this one was this. Why is that wrong? First you'll need to make, okay. To test the network, you'll need to NS lookup specifying the MX record type, the domain, and the DNS server to test resolution. Okay. Well, here's what we're going to do instead. We're not going to go through every single one of these questions. Well, we'll go through the ones I got wrong. And then we'll go we're going to go back over section 1, the concepts, because for whatever reason, that's the one that I struggle with the most. Okay? And that is 30% of the test. Okay, I'm not vibing with this music. Anybody else not vibing with this music? And what happened to all my other songs? Oh, there they are. Okay, good. Anyway. Okay, security analyst is looking at multiple packets from the same packet group. Which of the following fields corresponds to a conversion where it is broken apart due to the MTA size? And the answer is a sequence number. I thought it was header. I thought it added a header to it. Still not going to read it to me? Nobody wants to hear me read. Oh, here we go. Here we go.
Sequence number of the last byte in the segment allows the receiver to rebuild the message correctly and deal with out-of-order packets.
Okay. Got it. Next. Almost every single one that I flagged, I got wrong. There's very few that I flagged that I did not get wrong.
Security team is reviewing the authentication controls on the corporate network. Which of the following is an important reason for the team to implement role-based access and least privilege? Select 2.
Okay, I put to establish checks and balances against insider threats, which I feel like is a good idea, to grant users sufficient rights to perform a job. So that is also correct. But the one that I didn't put was to give rights to users implicitly. Maybe I don't understand the word implicitly. I thought implicitly meant like no matter what, like regardless. Let's look up this word.
Implicitly.
In a way that is not directly expressed. Oh, without qualification, absolutely. Yeah, that's what I thought. Without a qualification, absolutely. So, security team is reviewing the authentication controls in the corporate network. Which of the following is an important reason for the team to implement role-based access to least privilege? to give absolute control. I feel like I'm interpreting this wrong.
Least privilege means that a user is granted sufficient rights to perform his or her job and no more. This mitigates risk if the account should be compromised and fall under the control of a threat actor. Role-based access define organizational roles, and subjects are allocated to those roles. Users gain rights implicitly through being assigned to a role.
Oh, okay.
Being assigned the right directly. Zero Trust uses systems such as continuous authentication and conditional access to mitigate privilege escalation and account compromise. Another Zero Trust technique is to apply microsegmentation. Separation of duties is a means of establishing checks and balances against the possibility that critical systems or procedures can be compromised by insider threats.
Okay, that makes sense. So it's implicitly given based off of the title, rather than explicitly being assigned the right directly. Okay, that makes sense.
A user is having trouble downloading a file from a file server. A network technician checks the connection and that ping commands are receiving replies. The technician can also browse to the file server using the Windows Explorer. What should the technician begin to troubleshoot and why? Select all that apply.
So I selected 3. I selected if the file application is misconfigured, any TCP flags, and the application layer. The answer was if the file application is misconfigured and the application layer. So let's see here.
Multiple TCP connections are managed using handshake transactions, which make use of a number of TCP flags.
Why should the technician begin? So that doesn't really say why that is the answer. We're gonna go to our good friend Chatbot GPT here. Oh hey, look, this was my this is my thumbnail. Yeah, I've been exposed. That's correct. I use AI art in order to make all of my thumbnails. You can go and cry and be upset that I do that, but it's just so much faster and so much easier to create a little poo-poo thumbnail that doesn't matter. So anyway, let me oh, that's not what I wanted. Whoa, I don't know what's going on. Oh, it's because it's here. There we go. That should actually be. And this should actually be. There we go. Now we're cooking with gas. All right, here we go. Let's see here. Let's see what it has to say. I should have it set up. Yeah, I have it set up. Look at my prompt. My prompt's so good. It thinks it's the payload. Let's read the analogy here.
Imagine you're visiting a store. You can walk in the front door, ping works. You can see the items on shelves, browsing works. But when you try to buy something, download a file, something goes wrong. The problem likely isn't with getting into the store network layer. It's with the store's service, the cashier's system application misconfiguration, or how the item is being handed over payload.
Yeah, that's what I want. I want to analyze each of these and figure out why they are what they are.
If the file application is misconfigured, the issue seems to occur only during the download, not during connection. This strongly suggests the file sharing application like SMB, FTP, or HTTP may be misconfigured. Incorrect permissions, bad paths or broken shares, misrouted file handling, the application layer. This is layer 7 of the OSI model, where file sharing protocols operate like SMB, FTP, HTTP. Since lower layers ping, TCP, IP, DNS are working, the issue is most likely here. Troubleshooting the application layer includes protocols, services, authentication, file handling, configuration, the payload. Payload refers to the actual data being delivered in the packet. If there's a failure in file transfer corruption, size limits, encoding issues, the payload may be the problem. For example, antivirus blocking certain file types, application timeouts on large payloads, incorrect formatting. Any TCP flags. TCP flags like SYN, ACK, FIN, RST are part of layer 4, transport layer. Since ping works ICMP and browsing to the server likely over SMB or HTTP works, the TCP connection itself is likely fine. There's no indication of TCP level issues like session resets or incomplete handshakes. Not a priority in this scenario.
Okay, the user in the accounting window explorer to successfully connect. What are you doing? Weird cat. So technician confirms that we can ping successfully, server's reachable, and the file listing is visible. So they check whether the file server application is misconfigured, folder permissions, whether the application layer is working properly, whether the payload might be causing download failure. See, payload makes sense to me now.
In which of the following tables does a NAT router store port numbers and their associated private IP address mappings?
Translation table.
A NAT router stores port numbers and their associated private IP addresses in a mapping table. NAT uses this table to know which host to send the incoming traffic to.
Okay. Routing table is for routing packets from one network to another. I knew it wasn't MAC or ARP. MAC address tables are used by Ethernet switches to know where to forward traffic within the network segment. An ARP table associated MAC addresses. Okay, next. Which of the following scenarios best illustrates the use of PAT? Small businesses with a single IP address allows multiple employees to access the internet simultaneously. Simultaneously is the key word there. Crossover cable. We're just going to read it, make sure.
An engineer connects two network devices together that do not have the auto MDI MDIX enabled by default.
Two
The device
network devices together, they're insinuating that they are the same device, so therefore it is a crossover cable.
Most switch interfaces use auto MDI MDIX by default, based on current configurations. However, they can be disabled or enabled. If the auto MDI MDIX is not enabled, then connecting two MDI ports requires a crossover cable. Bidirectional refers to two-way communication. CompTIA Network.
So most switches interfaces use auto by default based on the current configuration. However, they can be disabled or enabled. If an auto is not enabled, then connecting two MDI ports requires a crossover cable. Straight through refers to cabling such as twisted pair cabling where pins on one end of the cable match the pins on the opposite end. Okay.
Named Specs has solicited the use of cloud services and has chosen a platform as a service PodAS's product from Oracle with an Oracle database. The company will use this platform to build custom applications on thin clients based in the cloud. Which of the following is true about this scenario?
Yeah, this is one that I definitely I struggle with quite a bit. So the answer was application security is handled by specs.
A platform as a service PaaS would provide servers and storage network infrastructure, but also a multi-tier web application database platform on top. The company would install custom software on the platform, for example, Oracle database, and be responsible for the security of the application. An infrastructure as a service IaaS model provisions IT resources like servers for a customer to configure. In this case, Oracle handles the configurations of all infrastructure. A software as a service SaaS model would provide the provisioning of software using an on-demand service. The service provider or Oracle would be responsible for the integrity, security, and availability of the platform components, for example, servers, storage, networking, and Oracle database.
Okay. Let's get an analogy.
3. Analogy. Imagine Oracle provides you with a ready-to-use kitchen, PaaS. The counters, appliances, and utilities are all set up. You, as the developer specs, must bring your own ingredients, recipes, and lock the fridge if you don't want others touching your food. So you build and secure your application using the tools they provide, but the kitchen's infrastructure is maintained by Oracle.
Okay. You build and secure applications using the tools they provide, but the kitchen infrastructure is maintained by Oracle. While Oracle manages the platform and underneath infrastructure, Specs is responsible for securing their own applications, authentication, authorization, input validations, and application level firewalls.
Five. Real-world example or scenario. Specs wants to build a custom CRM system for internal use. They choose Oracle PaaS with Oracle Database. Oracle provides pre-configured database, dev tools, for example, Java app servers, scalable infrastructure. Specs develops the application logic, manages user roles and authentication, ensures data input is secure, handles application layer security like encryption of sensitive fields. They don't touch server firewalls, can't reconfigure the OS, and don't get access to all Oracle software. Only what the PaaS package includes.
Okay.
A network engineer is troubleshooting a problem where a server cannot communicate with remote servers outside of its network. The engineer verifies that the server can ping its loopback address, its own. A network engineer is troubleshooting a problem where a server cannot communicate with remote servers outside of its network. The engineer verifies that the server can ping its loopback address, its own IP address, and the default gateway without any issues. However, attempts to ping remote servers time out. The engineer suspects a routing issue. What should the network engineer check first to diagnose the problem?
So I said the server's firewall settings for any rules blocking ICMP packets. The answer was the routing table on the router for any incorrect or missing routes. So what should, however, he attempts to ping the remote server, time out. The engineer suspects a routing issue. This is the key right there. The engineer suspects a routing issue. The routing issue means that it's probably a routing issue. Could it be a firewall thing? I mean, possibly. Let's find out. Let's see what it says and why that can't be it.
While firewall settings could potentially block ICMP packets, the network engineer has already verified communication with the default gateway, suggesting that ICMP is not completely blocked.
So since it was able to have communication with the default gateway because it was able to ping it with its loopback address and its own IP address, so then it makes sense. That's why it was the routing table. The physical network connection between the server and router, there's no way that's what it was. Okay. The IP address configuration on the remote server. I don't think that it could be that or why it would be that. I take my test literally in a day, so I need to make sure that I fully understand this stuff. Okay, so we can ping the loopback, we can ping its own address, and we can ping the defaults. The defaults is why we know that it's not blocking IMCP or ICMP. Okay. Let's look at analogy.
3. Analogy. Think of the server like a person in a building. It can talk to itself loopback. It can talk to people in the same room own IP. It can talk to the receptionist default gateway. But when it asks the receptionist to call someone outside the building, the call fails. This suggests that the receptionist's phone book routing table may be missing the number, or has wrong instructions on how to reach others.
That makes a lot of sense. That makes a lot of sense. Physical network connection between the server, not the issue. Server can ping. IP address configurations, even if the remote server was misconfigured, you'd still get a ICMP response like destination unreachable, that which was not the case. And since we are able to ping the gateway, we know that it's not the answer choice that I chose. All right. Cool, but the server is speaking to the headquarters, the gateway, but cannot hear. The network engineer logs into the router at here, finds the default route 0.0.0.0/0 is missing, meaning the route has no idea where to send traffic outside of the network. What I don't understand is how is this different from the gateway, the default gateway? Because isn't the gateway supposed to help you get outside? So how is this different from the default gateway? Isn't the default gateway supposed to get you outside of the local network? Boom, boom. Excellent follow-up question. Thanks, ChatbotGPT. You make me feel so validated. And let's answer this using 5-point breakdown. Okay, simplified answer. Tell me, maybe this will satisfy me.
2. Simplified answer. The default gateway gets traffic off your local subnet, but that gateway still needs to know where to send it next, which is where the routing table comes in. So, your device uses the default gateway to escape the local network. The gateway router uses its routing table to know where to forward your traffic next.
Okay. Give me a scenario. Or give me an analogy.
3. Analogy. Think of the default gateway as the front door of your house. You hand a letter to your mail carrier default gateway, expecting it to reach another city. But if the post office router doesn't have routing information, a map or address book on how to get to that city, your mail will sit there or get lost. So, default gateway equal to who you give the mail to. Routing table equal to how that mail gets to its destination once it leaves.
So, what if I'm trying to send something to someone that's like in, I don't know, like Australia or something? How am I going to know their routing? How do I know to route it that way? Isn't there protocols to set it? Or is this configuring or talking about it more like in terms of like a small thing? Like, no, because they're trying to get them out of the network. They're trying to get outside. No, they're not. They're trying to get outside the subnet because that verifies that the server can be pinged. So there's a troubleshooting problem where the server cannot communicate. So this is still an in-house problem, but we're trying to get outside. Okay, not outside into the WAN, but outside from the local subnet to like the HQ or something. Okay. This makes sense. Let's move on. This is another one that I struggle with.
An email administrator is setting up records for their new cluster of mail servers. What must each of their MX records point to?
Okay. An A record. So it needs to have an IPv4 or an IPv6.
The host identified in an MX record must have an associated A or AA record. A mail exchange MX record is used to identify an email server for the domain. In a typical network, multiple servers are installed to provide redundancy, and each one will be represented with an MX record.
Okay.
Imagine setting up a mail forwarding system. The MX record is like telling the post office, all mail for this domain should go to this address. But that address must be real and deliverable, not just an alias or nickname. So an MX record must point to an A record, which maps a host name to an IP address, the actual deliverable location of the mail server.
Okay, that makes sense. Let's look here. MX records don't point directly to an IP address. Instead, each MX record must point to a host name, and that host name must resolve via an A record. Example, yourdomain.com.nmx10 mail1.yourdomain.com mail yourdomain.com in a. Okay, that's making a little bit more sense. Real world scenario: an admin is setting up an MX record for company.com. They configure company.com in MX10, and then we have MX20, and then we have mail.company.com, and then here's the IP. Okay, so it needs to be connected because it needs to be able to connect it. Okay. All right, next one. Oh, buddy, man, I suck at these so hard.
To allow users to access their Windows workstations remotely using the native Windows Remote Desktop connection, what port should be opened up in any security appliance?
Remote desktop protocol. How could I miss that? How could I have missed that? You know what it was? It was because I saw these port numbers and I got freaked out. That's why. Okay, remote desktop protocol. I can't believe I missed that. Of course it's that. Like, there's no way. Like, it can't be Telnet. What is VNC? Is the virtual network computing is a remote access tool and protocol. VNC is the basic of Mac OS screen sharing. Really? Okay. And then this is not a direct standard, but a protocol used to query and update directory for UDP. So I picked the throwaway is what I picked. Okay, 42.
A multi-tenant third-party cloud service that is available via the internet can be described as which of the following cloud delivery models?
Public, because multi-tenant is public. Community is more like a hospital, like there's multiple things and they're all going toward it at once, and that they all share the cost too.
A public or multi-tenant model is hosted by a third party and shared with other subscribers. This is commonly known by consumers as cloud computing. A private model is completely private to and owned by the organization. This is geared more toward banking and governmental services that require strict access control. A hybrid model uses a mixture of private and public cloud services, which may be on-premise or off-premise. Virtual machines and services are able to migrate between the two. A community model is where several organizations share the costs of either a hosted private or fully private cloud. Security may be a concern with this implementation type.
Okay. The hybrid one is the one I don't really understand. Hybrid models use a mixture of private and public cloud services, which may be on-premise or off-premise. So they just do a mixture of private and public. Okay. And the private is a model is completely private to you and your own organization. This is geared more toward banking and governmental services. That kind of makes sense. Ooh. This one.
A network administrator is deciding which session control protocol they should use for their environment.
Okay. The only two that I knew what it was EGP, which I cannot remember what it stands for, and RIP. And I knew for a fact that it wasn't RIP. I did not know what these two were. Let's see what it says, and then we'll see what ChatGPT says.
The Session Initiation Protocol SIP is one of the most widely used session control protocols. SIP endpoints are the end-user devices, also known as user agents, such as IP-enabled handsets or client and server web conference software. While SIP provides session management, the actual delivery of real-time data uses different protocols. The principal one is Real-Time Transport Protocol RTP. The Routing Information Protocol RIP is a distance vector routing protocol. RIP only considers a single piece of information about the network topology. An Exterior Gateway Protocol EGP can advertise routes between autonomous systems. An EGP includes a field to communicate the network's autonomous system ID.
Okay. What do we got here?
Let's tackle this session control protocol question using your 5-part. 2. Simplified answer. Correct answer: SIP Session Initiation Protocol. 3. Analogy. Imagine setting up a phone call. SIP is like the phone operator. It sets up the call, connects the two parties, and ends the call when you hang up. It doesn't carry your voice. It just manages the call session. 4. In-depth explanation. SIP Session Initiation Protocol. Layer 5 Session Layer Protocol. Used to initiate, manage, and terminate real-time communication sessions such as VoIP, voice over IP video conferencing, instant messaging, handles, session setup, who's calling whom, ringing, call transfer, termination. Works alongside RTP, which handles the actual media, voice, video data.
So, like Discord would use SIP because it is voice over IP, it is video conferencing, it's instant messaging. It's literally all these things. So Discord is literally this. And I guess like Skype would be the same thing, although I don't think Skype exists anymore. Okay.
Now, let's look at the incorrect answers. EGP Exterior Gateway Protocol, a routing protocol, not a session protocol. Predecessor to BGP Border Gateway Protocol.
Oh, okay, it's a routing protocol. So that's the difference. It was a session protocol versus a routing protocol. That's what I got confused. Okay.
Used between autonomous systems, not for session control. RTP Real-Time Transport Protocol. RTP handles the media stream, voice or video packets. It works with SIP, but does not control the session. Think of RTP as the audio signal, and SIP as the phone operator managing the call. RIP Routing Information Protocol. An Interior Gateway Protocol IGP, used to route IP packets within a network, has nothing to do with session control.
Yeah, see, I knew that one was a bad one because I recognized it. So, okay, let's continue on. We're going to do the real-world example, then we're going to read the question again and make it all
5.
connect.
Real-world example or scenario. A company sets up a VoIP system using soft phones and IP desk phones. To make a call, SIP is used to establish the session between two users. It signals ringing, pickup, hang up, call hold, and forwarding. Once the session is established, RTP carries the actual voice data between devices. So if the admin is choosing a session control protocol, SIP is the clear choice. Let me know if you want to go deeper into how SIP works with RTP, or say next question.
Okay, an RTP handles the media stream, voice and video packets. It works with SIP, but does not control the session. So SIP controls the session, but RTP, Real-Time Transport Protocol, handles the packets. Think of RTP as the audio signal and SIP as the phone operator managing the call. Okay, and the actual question was...
A network administrator is deciding which session control protocol they should use for their environment. Which of the following would they use?
So, session control protocol. It's got to be SIP. And EGP is a routing protocol. And RIP is an interior gateway protocol, which is kind of like a routing protocol, but like bigger. Okay, this is making a lot of sense. Okay. I think I guessed on this one.
A network engineer conducts a redundancy check. and identifies that interference exists due to a poor quality cable. What is this issue called?
Yes, when we took this test yesterday morning, I guessed because I knew that it wasn't logging levels, and I knew that it wasn't MIB. I didn't know what CRC was, but I took a shot in the dark with CRC error because it was saying that there was an error here, and I was correct.
Interference usually causes CRC errors. This interference might be due to poor quality cable or termination, attenuation, mismatches between optical transceivers or cable types, or some external factor. The error checking field contains a 32-bit 4-byte checksum called a cyclic redundancy check, CRC, or frame check sequence, FCS. The logging level configured on each host determines the maximum level at which events are recorded or forwarded.
Okay, what is a checksum? A checksum is a small-sized datum preferred. Okay, hold on.
A checksum is a small piece of data that acts as a fingerprint for a larger block of digital data. Its primary purpose is to detect accidental errors or alterations in data during transmission or storage. Think of it like this. You have a book, and to ensure it hasn't been damaged or tampered with after being shipped, you calculate a unique numerical value based on its content before shipping. When the book arrives, you recalculate the value using the same method. If the two values match, it's likely the book arrived without any changes. If they don't match, it means something went wrong, and the data might be corrupted or altered.
Okay. That makes sense. Input, cryptograph algorithm, checksum output. Interesting. Okay. So just make sure that things stay and have their quality. So CRC is recycled redundant check or frame check sequence, which is FCS. The error checking field contains a 32-bit 4-byte checksum called. So this is a checksum. Okay. Logging levels configured on each host determines the maximum level at which the events are recorded or forwarded. The management information base that holds statistics related to the device activities such as the number of frames per second handled by a switch. All right. I need to focus. I just got distracted there for a second. So then it would have been a checksum error.
A network engineer conducts a redundancy check and identifies that interference exists due to a poor quality cable. What is this issue called?
So a redundancy check error. Recycle redundancy check. So that makes a lot of sense why that was the answer.
The end-to-end or host-to-host layer is another name for which layer?
The transport layer. That's what it is. Yes. Transport. Okay. Feel good about it. It's not data link. That's layer 2. Application is layer... Crap. What? Local. data link network transport session application okay, physical data network transport session presentation application. And transport is host to host. Transport's host to host. Session is it's starting, it's maintaining, and it's ending. Presentation is the encryption. So that's like, I think that's like DHCP and stuff like that. Oh, this is how the packets break down. That's crazy. Wow. Look at how all the packets break down. Data, HTTP layer, TCP header, IP header, MAC header. Then it's transferred into bits, and then it just unpacks it. That's wild. It literally is magic. Okay, here we go.
During a video conference, participants experience sudden drops in video quality and occasional freezes. Which of the following metrics should be closely monitored to diagnose the issue?
So I said latency and jitter. I don't know why I flagged this one, because it's obviously latency and jitter. Oh, because it said number of connected users. Although the number of users can impact the network performance, it does not directly cause a sudden drop in video quality and freezing that are sympathetic to high latency. That's true, because there could be a bunch of people on there, and it only affects your view of them. It doesn't really affect the individual. Okay. Here we go.
The correct answer is latency and jitter are critical metrics for real-time applications like video conferencing. Latency refers to the delay before a transfer of data begins following an instruction for its transfer, while jitter is the variation in packet delay at the receiving end. High latency and jitter can cause delays, packet loss, and out-of-order packets, leading to poor video quality and freezes during a conference. While bandwidth is important for video conferencing, sudden drops in video quality and freezes are more directly related to latency and jitter issues. High CPU usage can affect performance, but it is not as directly related to video quality.
Okay, let's move on to the next one. The primary purpose of network access control and NAC is to authenticate endpoints before they fully connect to the network. Okay, network access control to manage network traffic, to monitor network performance, to increase. I'm pretty sure it has only things to do with authentication. I don't think it has anything to do with really managing the network traffic more than that it just authenticates.
NAC's primary function is to authenticate and authorize devices before they gain full access to the network, ensuring that only trusted devices can connect. This is crucial for preventing unauthorized access and mitigating risks from rogue devices. NAC focuses on security through authentication and authorization, not on enhancing network performance or speed. NAC's role is in security, specifically in controlling device access to the network, rather than managing the flow or volume of network traffic. NAC is not a tool for performance monitoring. Its purpose is to secure the network by controlling device access.
Okay. All right, now this one that I got wrong. Let's check it out. Crap, I didn't know what any of these were. Well, no, that's a lie. I knew what this was, and I knew what this was. Actually, hold on. This is where it's talking about administrative distance. I just have to memorize these distances.
BGP has an administrative distance of 20. An administrative distance add value can express the relative trustworthiness of the protocol supplying the route. EIDRP has an administrative distance of 90%. Default add values are coded into the router but can be adjusted by the administrator if necessary. OSPF has an administrative distance of 100.
Yeah, 110. So I knew that this was 255. I didn't know static is 1, but this is 20. This is 90. And this is 110. So 110, 90, and 20. That's something that you just have to memorize. There's a lot of this crap that you just kind of have to memorize. I'm sure that once you start doing more and more of it, like it just gets reinforced, you know? But that's why I got that wrong. Unknown is 255. That's as far as it can go. Static is 1. BGP. I guess it doesn't matter what that is. I know it's a protocol. Same as this and this one. But it's not really asking about the protocol. It's only asking about the distance. So this is 90 and this is 110. Okay. Where'd my thing go?
A network administrator
right there.
wants a network switch to authenticate attached devices before activating their port on the switch. When combined, which authentication methods provide the means to validate a client's access to the network before being allowed access? Select 2.
So I was very uncertain with this one. Hold on. I got a phone call.
The Institute of Electrical and Electronics Engineers IEEE 800 and 2.1 times uses authentication, authorization, and accounting AAA architecture that are made up of 3 components: a supplicant, network access point, and AAA server. The Extensible Authentication Protocol EAP provides a framework for deploying multiple types of authentication protocols and technologies, many of which use a digital certificate on the server and/or client machines. Terminal Access Controller Access Control System TACACS Plus is a similar protocol to Radius and is often used in authenticating administrative access to routers and switches. The local authentication provider is the software architecture that underpins the mechanism by which the user is authenticated before starting a shell. This is a login Linux, or a logon, or sign in Microsoft. Three, analogy. Think of a building with badge access. 802.1 times is the security guard at the door. It won't unlock the door network port until your ID is checked. EAP is the badge verification system. It validates your identity through credentials, certificates, or other methods. Only when both are used together can the guard 802.1 times allow access based on validated credentials EAP. Five, real-world example or scenario. An enterprise wants only authorized laptops to access their wired network. They configure 802.1 times on the switches to require authentication before activating a port. EAP with certificates on all company laptops. When a laptop is plugged in, the switch via 802.1 times requests authentication. The laptop responds with EAP credentials, a certificate. If validated, the port activates and grants access. If authentication fails, the port remains disabled.
Okay. Apologies for that. If you just tuned in or anything like that, I was on the phone with my girl. She's a teacher and she just went back, so she was calling me about all the teacher things. Okay. Anyway, where were we? We were talking about this question right here.
A network administrator wants a network switch to authenticate attached devices before activating their port on the switch. When combined, which authentication methods provide the means to validate a client's access to the network before being allowed access?
So
Select 2.
The authentication method we're going to use is EAP and IEEE 802.1x. So the IEEE uses the authentication and authorization. I get those two words mixed up. It's hard to see them. And accounting, the AAA. Okay. Architecture that are made up 3 components. Network and access point. Man.
Supplicant, network access point.
Supplicant, that's what I thought. I can tell I'm hungry. I'm having a hard time focusing. Okay, and the other one is the
Extensible Authentication Protocol, EAP, provides a framework for deploying multiple types of authentication protocols and technologies, many of which use a digital certificate on the server and/or client machines.
Now, I remember when I did this, yesterday, I could not remember what this was to save my life. That's why I went with the local authentication. I knew that this was authenticate. Maybe I didn't know that A stood for authenticate, but I knew that it was associated with authentication. So that's why I went with the one that I went with. Let's look at an analogy real quick. I know I already played it. Let's play it again.
3. Analogy. Think of a building with badge access. 802.1 times is the security guard at the door. It won't unlock the door network port until your ID is checked. EAP is the badge verification system. It validates your identity through credentials, certificates, or other methods. Only when both are used together can the guard 802.1 times allow access based on validated credentials, EAP.
Okay. Let's look at a real-world scenario here.
5. Real-world example or scenario. An enterprise wants only authorized laptops to access their wired network. They configure 802.1 times on the switches to require authentication before activating a port. EAP with certificates on all company laptops. When a laptop is plugged in, the switch via 802.1 times requests authentication. The laptop responds with EAP credentials, a certificate. If validated, the port activates and grants access. If authentication fails, the port remains disabled.
All right. A remote authentication protocol mostly uses authenticated admin access to network access, not end user device. So this is not an end user device. Refers to authentication against local stored credentials like switch itself, not typically used in dynamic. That makes sense. Okay, let's keep on keeping on. Oh, I knew that this was the answer, but I hadn't done Cisco inputs in a long time. So I wanted to make sure that that's what it was. So to configure an SVI for VLAN 50, the command interface VLAN 50 IP address, and then you put the IP address, and then you put the subnet mask is used. This command creates the SVI assigned to the IP address, allowing it to act as a default gateway for the device in VLAN 50. This command is used to configure the subnet for or on a router, not an SVI. Okay. Man, that's crazy because I almost put that one. Oh, okay. This makes SVI is virtual. This right here that means that it's a port. That's a physical port that you plug into. VLAN 50 command is used to create VLAN 50 on switch, but does not configure a SVI. That's what I figured with that as well. And then switch port mode access VLAN 50 command is used to assign a switch port to VLAN 50. Okay. I really feel like I'm on the cuff of like really understanding this stuff. This one, man. Oh man, what's in my eye?
A security analyst is setting up detections to look for unauthorized domain transfers from their external-facing DNS servers. Which of the following ports should they monitor?
All right. So this is the one that has a lot of discrepancies. Man, I still can't type with my left pinky, like, at all. This one has discrepancies because depending on what article you read, what AI you use, it's going to say that it's UDP 53. So, but yet it says TCP 53? Man. Give me an analogy. Help me.
3. Analogy. Think of DNS as a library. Most people ask the librarian for a single answer, what's the IP for google.com? That's UDP53. But a zone transfer is like saying, give me a full copy of every book and shelf in the library. Because that's a much larger structured transfer. It uses TCP53 instead of UDP.
Because it's a larger transfer, it uses TCP. So a security analyst is setting up detections to look for unauthorized domain transfers from their external facing DNS servers. Which of the following ports should they be monitoring? Give me in-depth. Whoa. Here we go.
4. In-depth explanation. DNS traffic generally uses UDP port 53 for standard queries like resolving domain names, TCP port 53 for zone transfers, AXFAR, XOFR. Large responses if the answer doesn't fit in a single UDP packet, DNS seek-related transfers. TCP 53, used for zone transfers between DNS servers, especially XFR, full zone transfers. This is what attackers might attempt to exploit to download an entire DNS zone map of your domain. Monitoring TCP 53 allows you to detect and block unauthorized attempts to pull entire DNS records.
Okay. This is used for regular DNS queries like resolving example.com, not used for zone transfers. Monitoring UDP 53 is important, but it won't show unauthorized zone transfers. Okay. 443. I guess what I have a hard time understanding is how there's these ports and it'll be the same port, but UDP or TCP will use the same port and they'll use it differently. So I just have a hard time understanding exactly what is a port and how it can be used for multiple things and used differently. Like, it's not like port 53 is always receiving or always, like, I guess port 53. So is it kind of like there's two port 53s? There's port 53 that's used by UDP and port 53 that is used by TCP. It's not that there's actually two ports. It's just it kind of feels like that. Maybe I'm looking at it the wrong way. One thing that I've noticed when it comes to a lot of IT stuff is that IT people, even some of these trainings and stuff, do not do a very good job of explaining things. They don't do a very good job of making something make sense for the commoner, even for people who are interested in it and they want to learn it. They don't do a very good job of explaining. And the only thing I can think of is that, like, IT people are normally kind of, well, they're weird. They're normally kind of weird. They're usually a little socially awkward, and their mind is more methodical and more like problem-solving based, like puzzles, I would imagine. So they have a hard time making the connection of how they're viewing something to somebody else. And I can relate that to a lot because I make a lot of real-world connections that the normal person would not make.
5.
or even understand.
Real-world example or scenario. A security analyst wants to ensure that no attacker can perform a zone transfer (AXVAR) to pull internal domain names from the company's public DNS servers. They configure the external DNS server to allow zone transfers only from trusted internal IPs. A firewall rule in IDS appears to monitor TCP port 53 for suspicious outbound transfers. If an unknown IP tries to use TCP 53 to perform a zone transfer, the system raises an alert and blocks the request.
Yeah, I get what I'm struggling with the most is that I don't have a visualization of how ports in general work, and I don't have a visualization of how TCP and UDP use these ports. I think that's my trouble with them. I think if I had a general understanding of what exactly ports are and how they function and why they exist, like their purpose, and how they're utilized with TCP and UDP, I think that it would make a lot more sense. That might be something I have to come back to, maybe after lunch.
A network engineer has installed a new switch. What should the engineer check to troubleshoot the trunk port connected to the corporate network?
The link state. That's very simple. Maybe it wasn't simple for me then, but after doing all the labs that I did last night and tonight, the link state makes it's just obvious to me. There's no way that it's going to be latency, duplex, or speed, byte count. No, none of these.
A custom client application is unable to communicate with the internal Internet Information Services (IIS's) server. Pinging or establishing a telnet connection from a workstation to the server works normally using an IP address or FQDN. Which of the following are possible causes for this network issue? Select 2.
Okay, so probable causes for this, or possible causes for this, is going to be that the ISS service is not running and the TC ports are blocked. See, this is, again, like understanding in depth of like what ports are and how they function and why they're important is the gap in my knowledge. Let's go here real quick and explain to me what ports are, how they I feel like I spelled that wrong. How they function and how they work with UDP and TCP. Give me a visualization. Did I spell that right? I feel like I spelled that wrong. I spelled that wrong. Oh, there is a Z in it. Okay, to be fair, in the English language, there's like tons of letters that are silent. Well, that's it? Okay, I was about to say, like, am I just overcomplicating this? Okay, we'll let it finish doing.
What are ports and how do they function? In the context of computer networks, a port is a software-defined virtual endpoint where network connections begin and end. Imagine it as a numbered door or channel on your computer, specifically assigned to a service, process, or application, enabling that particular software to send or receive data across a network. Ports help computers sort the network traffic they receive, ensuring that different types of traffic are directed to the correct applications.
Okay, so it's made up, just like everything else in life. Okay, so the way I'm visualizing this, and we're going to finish reading it, so I could be totally wrong, but the way I'm visualizing this is that there's just like this open space void, and there's just information that is just traveling through this void, and it all is trying to get to this endpoint, but it's all getting confused and mixed up and everything like that. So then what we did is we created these ports to organize where things are. So now in this void, we just now have these ports, and only certain things can go in certain ports of where this information is coming from in order to get to where it needs to go to. Otherwise, it's just like raw information that is just like hitting you, because it's all trying to get to you. Come on.
How ports work. IP addresses and port numbers. Every device on a network, like a computer or server, has a unique IP address to identify it.
Okay.
When data is sent to that device, a port number is included with the IP address to specify which service or application on that device should receive the data. Together, the IP address and port number form a socket address, which is crucial for routing data precisely within a network.
Okay, so again, our void of emptiness space, you are the endpoint, and this information is trying to get to you, whether you asked for it or whether it's just trying to come at you. In order for it to be translated into something that makes sense and that you can read and understand, it needs to be organized. And these ports are doing that. It has an IP address to identify it and to identify where it's going. And then it knows what port it needs to go into, so that way it can go to the correct thing. So that way it can get to you. So that way you know what that information is. I'm trying really hard to make more of an analogy off of it.
Standardization. Port numbers are standardized and managed by the Internet Assigned Numbers Authority, IANA. There are 65,535 possible port numbers, divided into 3 main ranges.
Okay. I feel like that's important to know. So the internet is basically, or the ports on the internet, not just the internet, into 65,535. Because I know that everything has a port. Like, we could go here and we can type in, what is the port number of Xbox? So for performance on Xbox Live, you may need to forward the following ports on your router. All of these. Mysterious port revealed? What do you mean mysterious? That's not mysterious. That's obviously for a memory card. What are you, dumb? Anyway, let's get back to it.
Well-known ports 0 to 1023. These are reserved for widely
Well-known ports 1023. Get to it. These are reserved for widely used and standardized services like HTTP, which is port 80, web browsing HTTPS, which is 443, and web browsing, or for web browsing, FTP, which is port 21 for file transfers, SSH, which is port 22, Telnet is port 21 for secure remote access.
Used and standardized services like HTTP port 80. For web browsing, HTTPS port 443 for secure web browsing, FTP port 21 for file transfers, and SSH port 22 for secure remote access. Registered ports 1024 to 49,001, 151. These are used by specific applications and can be registered by organizations or software developers with IANA.dynamic/private. Ports 49,152 to 65,535. These are used for temporary connections, often on the client side, and can be dynamically assigned by the operating system to applications as needed. Multiplexing. Ports allow a single device to run multiple network services simultaneously. For example, a computer can host a web server on port 80 and an email server on port 25 without interference, according to Netrix. When data arrives at a device, the operating system uses the port number to direct the data to the correct application, a process called demultiplexing.
Whoa. So user, computer, client, web browsers, applications, port 80. Uses a dynamic port, clients 25, SSH 22.
TCP versus UDP and ports. TCP Transmission Control Protocol and UDP User Datagram Protocol are the two main transport layer protocols that use ports to deliver data. The choice between TCP and UDP depends on the specific requirements for reliability and speed. TCP Transmission Control Protocol, reliable and connection-oriented. TCP establishes a reliable connection between the client and server before data transfer begins through a three-way handshake process. Guarantee delivery. TCP ensures that all data packets arrive at the destination in the correct order and without errors. If packets are lost or arrive out of order, TCP handles retransmission and reordering. Checksums. TCP utilizes checksums to verify the integrity of the data. During transmission. Use cases. TCP is typically used for applications where data accuracy and reliability are critical, such as web browsing HTTP, HTTPS, email SMTP, POP3 IMAP, and file transfers FTP, SFTP.
File transfer protocol, S. So what about trivial file transfer protocol? Okay, so client, web browser, server, web server on port 80. Connection established, HTTPS request, web page content.
UDP, User Datagram Protocol. Fast and connectionless. UDP does not establish a connection before sending data. It simply sends data packets, datagrams, without verifying receipt or order. No delivery guarantee. UDP offers no guarantee that data will be delivered or that it will arrive in the correct order. Less overhead. This lack of connection setup and error checking makes UDP faster and more efficient than TCP. Use cases. UDP is preferred for applications where speed and efficiency are more important than perfect reliability, such as online gaming, video streaming, and voice over IP VoIP.
And that's how you get jitter and all that stuff, because you're losing packets. But it doesn't matter because it's constantly being fed. So client, gaming app, diagram, server, gaming server, port 3074. What is port 30? That's what I thought. Port, this is for Xbox Live for both UDP and TCP, because it needs to use TCP to pull up certain things. Well, I guess if you're pulling up a web browser, or UDP for the actual gaming. Okay. I'm just trying to connect it to things that make sense to me, you know what I'm saying? What? Okay, here we are. Give me a visualization.
Visualization. Imagine your computer as a large building with many specialized departments. Each department provides a different service, for example, mailroom, web office, gaming lounge. When a message arrives at the building, your computer's IP address, it also contains a number, the port number, indicating which department it should go to. TCP. Think of this as a registered mail service. Before sending a letter data to a specific department port, you need to confirm that the department is open and ready to receive it, the three-way handshake. Each letter is tracked and acknowledged, and if a letter gets lost or arrives damaged, it's resent, ensuring the entire message arrives intact and in the correct order. This might be slower, but the reliability is guaranteed. UDP. This is more like a drop-in-the-mailbox service. You send a letter to a specific department's mailbox port without any prior agreement or confirmation. The mail is sent quickly, but there's no guarantee it will arrive, be in the correct order, or even be delivered at all. However, for applications where a lost letter or two isn't a major issue, UDP's speed is beneficial. In essence, ports are crucial for allowing multiple applications and services to run on a single device and communicate effectively across a network. TCP and UDP provide different approaches to this communication, with TCP prioritizing reliability and UDP prioritizing speed. The appropriate choice of protocol depends on the specific requirements of the application or service in question.
Okay, I have a little bit better understanding and acceptance of what these ports are now. So what was this question again?
A custom client application is unable to communicate with the internal Internet Information Services IS server. Pinging or establishing a telnet connection from a workstation to the server works normally using an IP address or FQDN. Which of the following are possible causes for this network issue?
So based on what we just learned, just because you can ping and establish a telnet connection, which means that they are connected to the internet, or that they can be reached, doesn't mean that the port is open, which is why the port could be blocked. Okay. the ISS service is also not running. That could also be an issue as well of why you can't reach it. The SSL, the secure socket certificates, is not trusted. I always forget what a secure socket layer is. I have to remember this. A secure socket layer is a security protocol that establishes an encryption link between server and client, typically a web browser, ensuring secure communication over the internet. Okay, and that's why some people, you can use Telnet over an SSL. You can even use SSH over SSL. Secure socket layer. Got it. Is not trusted. Well, there was nothing that was indicated that made it seem like it was not trusted. And it's also in an internal internet, like internet information service. It's an internal one. So like, why would it be not trusted? The client cannot resolve the server name. Let's see what this says.
The application on the client workstation may be communicating over a blocked transmission control protocol (TCP) port. The workstation can communicate using Telnet via TCP port 23. Ports may need to be manually allowed in and out. The IS service may not be working, causing the client application not to connect as well. Services on a Windows computer is viewable using the Services Management Console, services.msc. As both a ping and telnet test are successful between the client and the server using both an IP address and the host name resolution is found to be working properly. The client was not accessing the IS server using a web browser, which indicates if a server certificate was installed or trusted.
Yep. Okay. Still not 100% solid, but I definitely have a stronger understanding of ports and TCP now.
On the multi-floor office, the staff is deploying multiple switches, and there must be multiple broadcast domains. A Layer 2 switch with a single broadcast domain requires more bandwidth as more hosts are connecting to it. How can these switches be set up to accommodate the network architecture?
Configuring multiple VLANs. Now, why is it not spinning tree? Is a switch protocol that prevents network loops. So, okay, this is just a protocol that prevents network loops. Got it. Configure multiple VLANs. VLANs can reduce broadcast traffic when network has expanded beyond its certain number of hosts or users. From a security port to view, each VLAN can represent a separate zone. Okay. Set up each port as a trunk port. Why wouldn't we want to do that?
The interconnections between switches are referred to as trunks. A basic setup will use one of the ports on each switch as a trunk port. Multiple VLANs can pass through these trunk ports by tagging each packet with the appropriate VLAN tag or ID.
So why is that? See, this is my like thing. Like, why is that not the answer then? I'm so hungry, dude. I just want to go eat lunch. But I gotta do this. Next question. Dang it. Now it's gonna just hallucinate and come up with something. Oh, no, it's not. Okay, that means that this thread's not broken yet. I want to know why it's not these questions.
3. Analogy. Think of a building where everyone is shouting across one big open floor. That's a single broadcast domain. To reduce the noise, you divide the floor into separate rooms, VLANs, where only people in the same room hear each other. Now each group communicates more efficiently without yelling over others. 4. In-depth explanation. The problem here is, a single Layer 2 switch means all devices are in the same broadcast domain. As more hosts connect, broadcast traffic increases, congesting the network and using up bandwidth. The solution is to break that large broadcast domain into smaller ones. Configure multiple VLANs. LAN's virtual local area networks logically segment a switch into multiple smaller broadcast domains. Each VLAN is isolated from the others unless routed through a Layer 3 device. This significantly reduces broadcast traffic, improves performance, and enhances security. Now let's go over the incorrect choices.
This is the one.
Set up each port as a trunk port. Trunk ports carry traffic from multiple VLANs across switches. But simply setting ports to trunk mode doesn't create VLANs or split broadcast
So
domains.
that's the answer.
In fact, access ports, not trunk ports, are what end-user devices typically connect to, each assigned to a specific VLAN.
So setting up a trunk port doesn't matter if we don't have VLANs. That's why it's not the answer. And that's why this is. Okay, port mirroring copies ingress and egress communications from one or more switch ports to another. This is used for monitoring purposes, not for reducing traffic or the broadcast demands. All right, that makes a little bit more sense.
A network technician is trying to determine which digital communication frequencies would be best at penetrating through the solid surfaces of the walls.
Okay.
Which of the following would be the best?
So 2.4 is better at propagating through solid surfaces, making it ideal for providing the longest signal range. That's why the mass majority of all internet and all Wi-Fi is 2.4. Because 2.4 is easier when it can just spread through walls way easier than 5. Why? I don't know. I don't really think it's necessary to know why it's better. We just need to know that it is better. Oh yeah, I took a shot in the dark. Well, I didn't take a shot in the dark in this one. I used my reasoning to make sure, but I struggle with the IaaS and PaaS.
An online company is seeing a quick customer growth in the utilization of custom online services. The company has forecasted a 300% increase of customer usage during the summer and currently cannot support this. Which of the following cloud solutions should the company consider when providing ongoing services to its customers? Select 2.
So this was tricky. So it wants the company to consider when providing ongoing services to its customers. So it needs a cloud-based solution. Since it said cloud-based solution and they're constantly growing, but they haven't grown big enough yet. So a hybrid model is the best. And then since it said cloud, I went with the IaaS. Let's see if that reasoning was correct.
Infrastructure as a service, IaaS, is a means of provisioning IT resources such as servers, load balancers, and storage area network SAN components quickly. Company virtual machines can easily be moved to the cloud infrastructure during the peak season. A hybrid cloud model provides the ability for the company to elastically move service from private to cloud infrastructure, and vice versa. This makes on-demand services cost-effective.
Yes. Virtual machines go with IaaS. That's a keyword that you can link together. Okay.
A network administrator wants to authenticate server machines using Transport Layer Security (TLS). What can the administrator implement on the servers to validate the server's identity and establish a secure transmission channel?
I thought it was going to be Cerberus. With Cerberus, clients request service from a server which relies on a key. Okay. So it doesn't use transport layer security, and it's just a password. It just enables a password. That's all it does. So the network administrator wants the authentication server machine using transport layer security. What can the administration implement on the server to validate the server's identity? Certificates. Digital certificates authenticate server machines when using TLS. The administrator installs the certificate on a web or email server to validate the identity and establish secure transmission channels. Okay. It's not going to be an SSO or a local authentication.
A dental office has a wide-range wireless access point AP configured to support the internal office network. The owner has requested to allow customers to connect to the AP for free Wi-Fi internet access. What should the network administrator configure to separate customer wireless sessions from each other and the internal office network? Select all that apply.
So I selected 3 things. I selected enable password complexity, enable MAC filtering, and enable guest network. The reason I put password complexity was to make sure that people weren't get onto the staff Wi-Fi. Okay. The reason I put MAC filtering is because you only want certain MAC addresses on the staff Wi-Fi, but I guess that doesn't make sense when it comes to phones. Okay. Enabling guest network. We do need that, but I didn't think enabling client isolation. The word client is overused in this so much. It can refer to someone who's trying to access the information from somewhere, but it can also be used to like access like a client of a business. Okay, so let's figure out why it is these 2 things.
A guest network can have separate security and forwarding policies applied to it than the network that permits access to the corporate LAN. Typically, a guest network is permitted access to the internet but not to local servers. An AP can use client isolation to prevent client communications in the same broadcast domain. This will help secure customer connections so they do not communicate with others on the same WLELAN.
So an AP can use client isolation to prevent client communication in the same broadcast domain. Okay. That makes a little bit more sense. Why is it not the other 2?
Media access control MAC filtering is a feature on a switch and access point that can be configured with an accept or deny list of known MAC addresses. Password complexity rules can help secure systems and user accounts. However, for a guest network, a simple password for access is sufficient.
Okay. So, like a lot of other things, I overthought this question.
A user is having trouble connecting to the company's Wi-Fi network. The user has verified that the password is correct and the network is available. What is the most likely issue with the device not connecting?
It is encryption protocol mismatch.
An encryption protocol mismatch will cause the connection to fail, even if the correct credentials are supplied. Check OS drivers or verify authentication types, protocols on the device.
Okay, this is important just to know.
An AAA server is an authentication server positioned within the local network. There are 2 main types of AAA servers, Radius and TechX. These would not be a part of the solution as an initial authentication connection is not taking place.
Okay. All right, 2 left. Let's finish strong.
Network architect is looking for a method process component that would help secure the network by not allowing unknown devices to forward packets. By ensuring that MAC addresses are becoming matched, what is assisting in protecting the network?
Now, when I did this, I was confused against this one and this one. So the CSMA/CD, that deals with collision denial detection. Collision detection. I see it. And then there's another one that is CA, which is collision avoidance. Okay. So that has to do with more of like buses. Duplex has to do with talking, and then flow control allows servers to pause traffic temporarily to avoid overwhelming its buffer and causing it to drop frames. Okay. So port security makes the most sense. Port security is a device that is attached to the port switch port from communicating on the network unless prevents unless it matches given MAC addresses or other protection profiles. Last one. And the reason I was stuck between phishing and piggybacking, I remember this question. And the reason I wanted to make sure that piggybacking is like tailgating, except it is allowing you to do it. Tailgating is the means of entering a secure area without authorization by following closely behind somebody. But piggybacking is an attacker that an employee gives permission. This is like the honeypot kind of thing, where like, you know, the government official like thinks he's gonna get lucky at the girl, and the girl convinces him to show him his lab. They go into the lab because she's showing interest in all these things, because men are really easy. All you have to do is show interest in their interest, and then like they think you're cool. And then that's when like it turns out she's a spy, and she like gets whatever, and that's a piggybacker. He allowed them into the secure area. Okay, so that makes total sense. Excellent. Okay, so here's what's gonna happen. We are going to end the stream. We're gonna come back at it later today around 4 o'clock, and we're gonna do more of the labs. Okay. We're gonna do wow, there's a lot. We might only do chapter 4. That is a lot. Okay, but we will slowly get through all of the labs. That is the whole goal of what we're trying to do, is get through these things to actually apply all the book knowledge. And then after that, my test is on Thursday. We'll probably take another practice test tomorrow morning. Tomorrow morning, we'll take another practice test. I might do some reviewing offline. And then Thursday, I'm going to go take my actual exam for the Network Plus, and we'll see where we're at. But we will, even after we take the exam, we will still continue doing all of these. And then we're going to do the packet tracers. And then we're going to get the, what's it called? Oh, I'm going to finish building the server. And we're going to talk about how I'm going to build my home server. And that's going to be really, really fun too. So hopefully I can actually get some videos actually pumped out and made that that aren't just live streaming and stuff like that. I do think that I am going to turn each one of these labs turn into a speed run, and maybe I'll make them into YouTube shorts, so that way people can always just access them instead of going through this, what is it now, like 4 hours of a stream kind of thing. But anyway, that's what's going on. If you're new to the stream, my name's ParaDiddlePete. I do tech stuff. I do things that I find enjoyable, or, you know, stuff. I just think learning is cool, I suppose. Maybe that makes me lame. Yeah. Next stream is going to be today at 4 o'clock. So if you're interested in that, go ahead and go check it out. Like, subscribe, do all of those good things. And I will see you guys later. Makala Checo.